We're going to continue today with trig equations. In particular, we're going to be talking about quadratic trig equations, and we're going to also talk about a type of equations called multiple angle trig equations. So let's start with quadratic trig equations. So with quadratic trig equations, you want to factor if possible, like we were doing before. But if factoring is not possible, then you are going to have to use the quadratic formula, just like you would with any other type of quadratic equation. So always check to see if you can factor, and if not, use the quadratic formula. So let's do some examples with quadratic trig equations. So here's the first one. 2 times sine squared minus sine minus 1 equals 0. Now, again, if you would like to help you factor, you can feel free to replace the function, the trig function, with a variable. So if you want to, you can write this as 2x squared minus x minus 1 equals 0. Now we can factor this by splitting the middle. It should split into -2, +1, factor out of 2x. So we should end up with 2x plus 1, x minus 1. Now that's going to be, in terms of the trig function, 2 times sine of x plus 1, sine of x minus 1 equals 0. And now that you have it factored, you can go ahead and set each factor equal to 0 and solve each of those equations. So we have 2 sine of x plus 1 equals 0, and sine of x minus 1 equals 0. Let's start with the one on the left. So isolating sine of x, we have sine of x equals -1/2. Now you want to think about, where do we have an angle measure where sine of that angle measure is negative? So sine is negative in quadrant 3 and quadrant 4. With a reference angle of pi over 6, in quadrant 3 that would be 7 pi over 6. Now don't forget, in this problem it says find all solutions. So that would be 7 pi over 6 plus or minus 2k pi. And then in quadrant 4, that would be 11 pi over 6 plus or minus 2k pi. Now for the second one, sine of x minus 1 equals 0. Adding 1 to both sides, we have sine of x equals 1. So now you want to think back to your unit circle. And on the unit circle, where is your y coordinate? Remember that sine corresponds to the y coordinate. Where is the y coordinate equal to 1? At the top of the unit circle, right? So that's when the angle measure is pi over 2. So x is equal to pi over 2. And don't forget, this is all solutions, so this is plus or minus 2k pi. Let's do another quadratic example. 2 sine squared of x plus 3 cosine of x minus 3 equals 0. Now again, this is not a typo. It is, in fact, a cosine of x in there and a sine squared of x in there. So we want to make sure that we get this down to just one function, one trig function, before we try to start factoring. So in this case, sine squared, we know we can replace that with 1 minus cosine squared because of a Pythagorean identity. So let's go ahead and do that. And we'll go ahead and simplify this as much as we can. So it looks like we will want to distribute that 2. The 2 minus 3 gives us a -1. It's combining like terms. I personally like to have the first term be positive. So if I multiply through everything by -1, or you can think of it as moving everything over to the other side, that would be 2 cosine squared minus 3 cosine of x plus 1 equals 0. Okay, now you can think of this as 2x squared minus 3x plus 1 equals 0, if that's helpful. And we can go ahead and try to factor that, try to split the middle here. So splitting the middle, we have two numbers that multiply to +2, add to -3, that would be -1, -2, split the middle. We should end up with 2x minus 1, x minus 1, or in terms of your trig functions, that would be 2 cosine of x minus 1, cosine of x minus 1. Set each of those equal to 0. And then let's isolate the function. And now let's go ahead and figure out what x has to equal. So starting with cosine of x equals 1/2. The value that would give us a positive value for cosine. Think about which quadrant you have to be in. So cosine of x is equal to 1/2. That has to be in the first quadrant and then in the fourth quadrant. Now your reference angle is pi over 3, so in the first quadrant, x would be pi over 3 plus or minus 2k pi, because it's all solutions. And in the fourth quadrant, just shy of 2 pi, that would be 5 pi over 3 plus or minus 2k pi. And for the second part, cosine of x equals 1, think back to your unit circle. Cosine, remember, corresponds to the x-coordinate of the unit circle. So you think about where on the unit circle is the x-coordinate equal to 1, and that would be on the right side of the unit circle, where x is equal to 0. So x equals 0 plus or minus 2k pi. Okay, now let's talk about what these trig equations with multiple angles would be. So a trig equation has what we call multiple angles if the variable is multiplied by something. So for example, if you have a sine of 3x, that would be a multiple angle because it's not just sine of x, it's sine of 3 times x. Or it could be something like this, cosine of x over 2. So this would be 1/2 times x, right? So when you're solving these trig equations, we could have fewer or more solutions within the unit circle. Now, how do you know which one you would have, fewer or more? Well, you're going to have fewer solutions if the coefficient that you're multiplying that variable by is less than 1. So for example, we had cosine of 1/2 times x up there. That's going to have fewer solutions because the coefficient is 1/2. It's less than 1. So you can think of it this way as well. Whatever number you're multiplying by, that's actually going to tell you exactly how many or how few you have in terms of the number of solutions. So in this case, cosine of 1/2 times x, you're multiplying x by 1/2. So rather than having the normal number of solutions, you will have half the number of solutions. Now, if the coefficient is greater than 1, then you will have more solutions. So for example, sine of 3 times x, the coefficient there is 3, which is greater than 1. So how many more solutions do you have? You have 3 times the number of solutions. Now, if you're asked to find solutions between 0 and 2 pi, be sure you are finding all and only those. Now, if you're ever asked to find all solutions, then you're really just tacking on the plus or minus 2k pi, and you should be all set. However, when you are asked to find the solutions between 0 and 2 pi, you're going to have to use that in order to help you determine what those solutions are. Let's take a look at example 3. So find values on 0 to 2 pi which satisfy this equation, 3 times tangent of x over 2 plus 3 equals 0. We're going to start it off the same way. We're going to try to isolate the trig function. So tangent of x over 2, get that by itself. So we'll subtract 3 and then divide by 3. That gives us tangent of x over 2 equals -1. Now, if it helps you, you can feel free to replace the x over 2 with just one variable. Just remember that at the very end, you are solving for x, so you'll have to do a substitution again. So let's go ahead and try that. So let's say instead of x over 2, I'm going to let u equal x over 2. So tangent of u is equal to -1. What does u equal in this case? Well, tangent is negative in which quadrants? In quadrant 2 and in quadrant 4. So in quadrant 2, tangent would equal -1 when u is equal to 3 pi over 4. And in quadrant 4, that would be at 7 pi over 4. Right? We're using a reference angle of pi over 4. Now that we've solved that portion, now we can say, well, remember that it's not u that we're trying to solve for, we're trying to solve for x. So instead of writing u equals 3 pi over 4, let's write x over 2 is equal to 3 pi over 4. We're just resubstituting it back in there. So x over 2 equals 3 pi over 4, and x over 2 equals 7 pi over 4. Now, we're going to solve for x, so if you multiply both sides by 2, to get x by itself, we have x equals 3 pi over 2, and over here, if we multiply both sides by 2, we end up with x equals 7 pi over 2. Now look back at the problem. You were trying to find values between 0 and 2 pi. The way that we've gone about solving this has been the same. But here's the thing. 7 pi over 2 is outside of the range from 0 to 2 pi, right? 7 pi over 2 is way more than 2 pi. So that means that here we actually only have one solution, x equals 3 pi over 2. And if you look back at the coefficient that was next to the x, or that we multiplied the x by, it was 1/2, right? So that tells us that we should have half the number of solutions. So we were able to find two solutions, and since in this case it's 1/2 times x, then we only have half the number of solutions. Okay, the next example, 2 times cosine of 3t minus 1 equals 0. So let's again go ahead and try to get that cosine function isolated. So we're going to add 1 and divide by 2. So we have cosine of 3t equals 1/2. Again, do the u substitution. So cosine of u is equal to 1/2. And now we have to figure out, okay, what does u have to equal? In order for cosine of u to equal 1/2, that's a positive 1/2, which means we must be working in the first quadrant, and we must be working in the fourth quadrant. So in the first quadrant, with a reference angle of pi over 3, u is equal to pi over 3 plus or minus 2k pi. In the fourth quadrant, with a reference angle of pi over 3, that would be 5 pi over 3 plus or minus 2k pi. Okay, now instead of writing u equals, remember we're solving for t, so we're going to, since we did the substitution that u is equal to 3t, now let's write that 3t is equal to pi over 3 plus or minus 2k pi. We're going to get t by itself, so we're going to have to divide both sides by 3 or multiply both sides by 1/3. So when we do that, now we have t equals pi over 9 plus or minus 2k pi over 3. In the second one, do the same thing. So divide both sides by 3. We end up with t equals 5 pi over 9 plus or minus 2k pi over 3. Now this is how you would come up with the solution if you were asked to find all solutions, right? You have to have that plus or minus 2k pi when you do the u substitution, and then divide or multiply accordingly in order to get your answer for t. Now, if for this problem you were asked, instead of find all solutions, you were asked to find solutions between 0 and 2 pi, you would only have found pi over 9 and 5 pi over 9. That's only two solutions. Normally we would have two solutions, but because this is 3 times t, that means we should have 3 times the number of solutions. We should have 6 solutions. So how do you find those? Well, I would suggest doing exactly what we did here, as if you were finding all solutions, and then when you get to actually coming up with the solutions between 0 and 2 pi, well, pi over 9 and 5 pi over 9 are two of those solutions. But to find the other ones, you're going to have to use that 2k pi over 3. So for example, here, pi over 9 plus, if let's say k is equal to 1, we would do 2 pi over 3. We would add those together. We would be adding 6 pi over 9, so that would be 7 pi over 9 would be another solution, which is also between 0 and 2 pi. And you want to continue, so let k equal 2, so you would be adding 4 pi over 3 to pi over 9. Now 4 pi over 3 with the same denominator would be 12 pi over 9, so 12 pi over 9 plus pi over 9, that's 13 pi over 9, which is still less than 2 pi. You would continue on until you get to a value that's more than 2 pi, and you know you can stop there. Do the same thing with the other answer, 5 pi over 9 plus 2 pi over 3, 5 pi over 9 plus 4 pi over 3, and continue on until you get all your solutions. In all, you should have 6 solutions if you are asked to find all the solutions between 0 and 2 pi.